In this part of the tutorial, we're setting up a basic React form. First, we import React and useState, a hook that lets us add React state to our function components. Now, we define our form component. Inside it, we initialize our form data state using useState. Here, form data is an object with two fields, name and email, both initialized to empty strings. Next, we create a handle change function. This function is triggered whenever the input values change. It updates our form data state with the current values of the input fields. Notice how we use the spread operator to maintain the existing street. Now, let's dive into adding validation to our form. We begin by defining a state called errors using useState. This state will store our validation error messages. Next, we create a function named validate. This function checks if the form fields meet our specified criteria. For instance, we check if the name field is not empty and if the email field contains a valid email address. We use regular expressions for the email validation. If a field doesn't meet the criteria, we add an appropriate error message to our temp errors object. After checking all fields, we update our errors state with temp errors. Our validate function returns true if there are no errors, indicating the form is valid. Finally, we have a handle submit function. This function is called when the form is submitted. It prevents the default form submission behavior using prevent default. We then call validate. If it returns true, meaning our form is valid, we log the form data. If not, we log a message indicating the form is invalid. This setup ensures users get immediate feedback on what needs to be corrected before they can successfully submit the form. In this step, we're enhancing our form by adding a new field for password. Just like we did with the name and email, we start by updating our form data state. We add a new key-value pair for the password, initializing it with an empty string. This ensures that we can capture and handle the password input from the user. Next, we add a new input field in our form. This input field is of type password, so that here we're going to handle the form submission process. First, we introduce a new state variable, isSubmitting, using useState. This Boolean flag helps us track whether the form is currently being submitted. We initialize it to false. Now, let's focus on the handle submit function, which is asynchronous. When the form is submitted, we prevent the default form submission action using prevent default. Then, we set isSubmitting to true, indicating that the submission process has started. Next, we check if the form is valid using our validate function. If it is, we proceed to submit the data. We use the fetch API to send a post request to a mock API endpoint. We convert our form data to JSON format and include it in the request body. We also set the appropriate headers for the request. After sending the request, we check the response. If it's successful, we log a success message. Otherwise, we log an error message. In case of any exception during this process, we catch it and log the error. Finally, whether our submission is successful or not, we set isSubmitting back to false. This completes the form submission logic, handling both client-side validation and server-side interaction seamlessly. Now, let's integrate our error handling into the form. We wrap our input fields and the submit button inside a form element with an onSubmit handler set to our handle submit function. This setup allows us to handle the form submission in one place. Look at each input field, for instance, the name and email. Right after each input, we use a conditional rendering to display error messages. If there's an error for a specific field in our errors state, like errors.name or errors email, we display it in a span element. This immediate feedback is crucial for a good user experience, as it guides the user to correct their input on the fly. Lastly, notice the submit button at the end. We've added a disabled attribute, linked to the isSubmitting street. In this part, we're going to enhance user experience by focusing on the first input field with an error. This makes it easier for users to start correcting their inputs immediately. To achieve this, we use React's useRef and useEffect hooks. First, we create a ref called firstInputRef using the useRef hook and attach it to the first input field in our form, which is the name input. The useRef hook allows us to directly interact with a DOM element in our component. Next, we use the useEffect hook, which runs after every render cycle. Inside useEffect, we check if there are any errors by looking at the keys of our errors object. If there are errors and the first input field is present in the DOM, checked by firstInputRef current, we set the focus on this input field. This is done using firstInputRef current focus. By doing this, as soon as an error occurs, the focus automatically shifts to the first field with an error guiding. Now, let's enhance our form validation by introducing real-time validation as the user types. This feature will provide immediate feedback, making our form more interactive and user-friendly. To implement this, we're going to use the useEffect hook from React. Inside our useEffect, we set up a timeout. This timeout delays the validation function by 500 milliseconds after the user stops typing. We do this to avoid running validations immediately with every keystroke, which can be overwhelming and inefficient. The timeout ensures that the validation runs only after the user has paused typing, providing a balance between instant feedback and performance. We link this effect to our form data state. This means that the effect runs every time form data changes, which happens every time the user types something in an input field. To clean up, we return a function from useEffect that clears the timeout. This cleanup function prevents memory leaks and ensures that the previous timeout is cleared before setting a new one, making our form component efficient and responsive to user inputs. In this part, we're going to optimize our form validation using a technique called debouncing. Debouncing is particularly useful in situations like ours, where we want to perform an action after the user has stopped typing for a certain period, rather than on every keystroke. It enhances performance and user experience. Here, we create a custom hook called useDebounced validation. This hook takes a validation function and a delay as its parameters. Inside the hook, we use the useState hook to keep track of. In this step, we'll integrate our custom debouncing hook, useDebounced validation, into our form component to optimize validation. First, we continue using useState for managing form data and errors. Next, we define our validation logic in the validate function. This function checks if the name is empty and if the email is in a valid format, updating the errors state accordingly. Now, here's where our debounced validation comes into play. We use the useDebounced validation hook we created earlier, passing our validate function and a 500 millisecond delay as arguments. This returns a debounced version of our validation function, which we store in debounced validate. In our handle change function, which is triggered on every input change, we call debounced validate. This means that our validate function will now be invoked only after the user has stopped typing for 500 milliseconds. This approach significantly reduces unnecessary validations and enhances performance, especially in cases where the validation logic is complex or the form is large. The result is a more responsive and efficient form experience. In this part, we're addressing a common pitfall in form handling, ensuring proper form submission. We start with our handle submit function. As usual, we prevent the default form submission using prevent default. Then, we check if our form is valid using the validate function. If the form is invalid, we log an error and exit the function early. This prevents the form from being submitted if there are validation errors. Next, we set our submitting state to true, indicating the start of the submission process. We then try to submit our form data to a server using a hypothetical submit form data function, which sends a request to the server. If the server responds with an error, response OK is false, we update our error state to include a server-side validation error. This is crucial for handling cases where the server might reject the data for reasons not caught by our client-side validation. If an error occurs during the submission process, we catch and log it. Finally, whether the submission is successful or not, we set is submitting back to false, resetting the form's submission state. This approach ensures that our form handles both client and server-side validations effectively, providing a robust user experience. Now, let's talk about how to handle server-side validation feedback in our React form. Often, you might need to pre-fill your form with data fetched from a server, or handle server-side validation errors. Here's how you can do that. In this example, we're using the useEffect hook to fetch initial form data from a server. When our component mounts, indicated by the empty dependency array in useEffect, we call a function named fetchData. This function uses the fetch API to request data from a mock API endpoint. If the fetch is successful and we receive a positive response OK is true, we use the response JSON method to parse the JSON data. We then set this data as our initial form data using the setFormData function. However, if there's an error during the fetch, we catch it and log it to the console. This pattern is essential for handling data fetching in real-world applications. It ensures that our form can dynamically load and display server-side data, and also handle any errors that may occur during this process. This makes our form more robust and user-friendly. Making our form accessible is crucial, and that's what we're focusing on now. We're adding ARIA, Accessible Rich Internet Applications, attributes to improve the accessibility of our form, especially for users with screen readers. In our form inputs, we add the ARIA invalid attribute. This attribute is dynamically set to true if there's an error associated with that input field. For example, if there's an error in the name field, ARIA invalid is set to true for the name input. This informs users with screen readers that there's something wrong with their input. Additionally, we use ARIA describedB to link our input fields with their respective error messages. This is done by assigning an ID to the error message span and referencing that ID in the input's ARIA describedB. For instance, the name input has ARIA describedB equals name error, and the corresponding error message has an ID of name error. This connection ensures that screen readers can convey the error messages associated with each input field, making our form more inclusive and user-friendly. By incorporating these ARIA attributes, we're not only making our form more accessible but also enhancing the overall user experience, ensuring that everyone can navigate and use O. Testing is a crucial part of developing robust applications. Here, we're going to write tests for our form validation logic using React Testing Library. This library offers a user-centric approach to testing UI components, ensuring that they work as expected. First, we test the validation of the name field. We render our form component using the render function. Then, we use screen getByPlaceholder text to get the name input field. We simulate user input with fire event change, setting the value of the name field to an empty string. After that, we trigger a blur event to simulate the user moving away from the input field. Finally, we use expect and getByText to check if the error message name is required is displayed. Similarly, we test the email field validation. We again render the form component, get the email input field, and simulate changing its value to an invalid email address. We then verify that the appropriate error message email is not valid is displayed. These tests help ensure that our form validation logic is working correctly, providing confidence in the reliability of our form's user interface. This approach is invaluable for maintaining high-quality, error-free user experiences. In this part, we're tackling an advanced validation pattern, ensuring that two password fields match. This is common in forms where users are required to confirm their passwords. We start by defining a function, validate password confirmation. This function compares the password and confirm password fields in our form data. If they don't match, we update our error state with a new error for confirm password, indicating that the passwords do not match. If they do match, we clear any existing errors for this field. Next, we have the handle password change function. This function is called whenever the user types in either the password or the confirm password field. It updates the form data with the new value. If the change is in the confirm password field, we call validate password confirmation to check if the passwords match. Finally, we add the confirm password input field to our form. It's similar to the other input fields, but it uses the handle password change function for its onChange event. Beneath this input, we display any error message related to confirm password validation. This setup ensures that users are immediately informed when their passwords don't match, enhancing the form's usability and preventing common mistakes. Performance optimization is key, especially for larger forms. In this example, we're using React's useMemo hook to optimize our form validation. This approach is particularly useful when you have complex validation logic that doesn't need to run on every render. We start by declaring our form data and errors state using useState. Then, we introduce a new constant, isFormValid, which we calculate using useMemo. The useMemo hook takes a function and a dependency array. The function calculates whether the form is valid based on our validation criteria. The name must not be empty, the email must match a standard format, and the password must be present. The beauty of useMemo is that this validation logic is only re-evaluated when form data changes, as specified in the dependency array. This means that if other state variables change or the component re-renders for another reason, our resource-intensive validation logic won't run unnecessarily. Finally, in our handle submit function, we check isFormValid before proceeding with the form submission. This pattern ensures that our form remains efficient and responsive, even as it grows in complexity and size.